to the experiment number 9, determination of resonant frequency, bandwidth and quality factor of a RLC circuit. Aim and application. Aim is to find the W0, F0, VC at W0, Imax bandwidth and off power frequencies F1 and F2 and observe at resonance voltage drop across L and C is 0 for the circuit shown in the problem sheet. Here we see in the circuit where the R1 is also known as V1. And let's see the difference between the inductive reactance against the frequency and capacitive reactance against the frequency. Draw the graph between frequency and reactance on the both sides. And we know that inductive reactance equals to 2 pi FL and the graph is linear curve. And similarly, capacitive reactance is 1 by 2 pi FC and the graph is hyperbolic curve. When these two curves merge together, the meeting point is known as F0 or resonance frequency. At the lesser the frequency, capacitive reactance is greater and inductive reactance is smaller. As similar, higher the frequency, Xc or capacitive reactance is smaller and inductive reactance is greater. And it is the curve which gives us the resonance frequency. It is a graph between frequency and I, and the midpoint of this curve is F0 or resonance frequency when the I max by root 2 or IRMS. The meeting point of RMS and curve are known as F1 and F2 or half power frequencies, and the gap between the curve and half power frequencies is called bandwidth. And we need to find W0, F0, VCA, W0, Imax, bandwidth and half power. Let's find the W0 and F0 and to find Imax. We know that F0 equals to 1 by 2 pi root LC and W equals to 1 by root LC radians per second or W0 equals to 2 pi F0. By substituting the values we get F0 equals to 159.155 edges and W0 equals to 1000 radians per second, and we know that V1 equals to Imax into 125. At the resonant frequency I is maximum, and by applying the mesh current analysis to find Imax, we get the equation as 125 plus 10 into Imax and minus 1.05 into V1 or minus 1.05 into Imax into 125 plus XL I Imax minus XC I Imax equals to 15. At resonance, we know that XL equals to XC. By substituting the values, we get that Imax equals to 4 amperes and R equals to V in by Imax. By substituting the values, we get R equals to 3.75 ohms. And to find VC at W0, we know that V equals to Imax into XC. VC equals to Imax into 1 by W into C. By substituting the values, we get VC equals to 16,000 volts. And to find the half power frequencies, formula for F1 and F2 depends on the quality factor Q, and we know that Q equals to W0 into L by R. By substituting the values, we get Q equals to 1066.67 as Q is greater than 1. F1 equals to F0 minus R by 2L. By substituting the values, we get F1 as 159.08 edges and F2 as 159.229 edges. And finally, to find the bandwidth, we know that bandwidth equals to F2 minus F1. By subtracting the F2 minus F1, we get bandwidth as 149.2078 millihertz. In PSpice, we get as A1 minus A2. Let's see the circuit connection in the PSpice. Components required: VAC1, resistors 2, inductor 1, capacitor 1, E1 and analog ground 1. Let's draw the circuit. By clicking on the get new port, we can get dialog box. Here type for the resistor R and click on the place and close option. Here we can see the resistor on dot sheet. Place the resistors according to the circuit, and for component E, type E, click on place and close, and for inductor L, and for capacitor C, and for VAC, and finally for the analog ground. By using the draw wire option, close the connection. Let's connect the E component later. Here we can see the two terminals positive and negative, and here in circle you can see the positive and negative again. Whereas in circuit we see it is a voltage dependent voltage source. Here the voltage source negative and positive is connected to the 10 ohms and inductor respectively. Here in the circle where we see the positive and negative or the voltage source, just connect according to the circuit, and as positive to the inductor and negative to the second resistors. And the voltage independent source V1 is connected to the R1 and negative to the second side. As by default, we see the resistor value is 1K. Change the values, and right clicking the values, we can get the set attribute value dialog box. Here we can change the values. For R1, 125 ohms, and for R2, 10 ohms, and for inductor, 4 henries, and for capacitor, here we can see it is a 1 by 4 microfarads, but in PSpice we cannot type the 1 by 4. So we have to type it as 1 by 4 as 0.25 U, and voltage as 15 volt. Place the current marker at the inductor. Now click on the component E. Here by default the gain is 1, but here we can see the gain is 1.05. Just change to 1.05 and click on save attribute and then on OK. Now click on the setup analysis. Here you can see the dialog box and click on the sweep, and by default total points is 101. Change it to 10 lakhs and starting frequency to 158 and end frequency to 160. Here we given the starting frequency and ending frequency as 158 and 160 because on theoretical calculation we got F1 and F2 as 159.08 and 159.22 respectively. So I entered the nearby values of F1 and F2 as starting frequency and ending frequency respectively. Now save the file and click on the stimulate option. Here it will take more time than any other experiment because it has to calculate the 10 lakh points. Here we can get the curve which gives the resonance frequency, and here you can see the toggle cursor option. Click on that, and here we can see the dialog box A1 and A2. Just right click at the curve and now click on the cursor peak option. Here we can get the line which is made of the curve which gives the F0 value or resonance frequency where A1 has 159.155.
So thank you, Rohit. So as you can see, Rohit has explained the theoretical calculations. So let me show you how do we proceed here with the simulation. So Rohit has also told like how do we do simulation and what all parameters has to be set in the setup analysis and how do you get your output. Now to verify your Imax, we have found current in the circuit and you can see appears 4 amperes. So we have to also verify your F0. So at F0 we have got maximum current, that is 4 amperes. So click on toggle cursor and then cursor peak. So you can see the y-axis is 4 and your x-axis is 159.155, which is same as your resonant frequency in your theoretical calculation, that is F0. Now, so after this we should also find what is your voltage drop across capacitance. So to do that, what you can do is you can go to trace voltage drop across capacitance is VC1 colon, click on this and say add. Now do not simulate again and again, as it takes, I think you might have experienced, it takes lot of time for simulation. So find one parameter, go to add trace and type the parameters that you want to find, then you can find out your unknown variable. Now I want to find what is the voltage across capacitance. As you can see, it is 16K, right? But here in cursor 1 as A1, you can see 4 amperes. That's your current. So let me first delete this. I'll select current through capacitance. I'll delete. Now you can see the peak value is 16,000. So just for verification, click on toggle cursor and cursor peak is 16,000 volt. Okay, and you can see at resonance frequency we have achieved it. Thus we have verified at resonance the voltage of across capacitance is 16 kilo or 16,000 volts. Now they've also asked you to observe that voltage of across LNC is 0. So for that, go to add trace and I'll type the code and then I'll verify that. Right, now you can see I've typed as voltage drop across L1 1 comma C2 2. Let us understand what exactly is it. So here you can see this is my probe. I've placed it, but even after I place, I get same equation. So L1 has two ends. This is 1, this is 2. C1 also has two ends. This is 1 and 2. So L1 is at position 1 is my positive. At 2 I have, at C1 I have placed negative. So negative of my voltage probe is at C1 2. I repeat, I must find voltage across L and C, that is L1 and C1. Plus is at L1 1 and negative is at C1 2. That is why I have typed this code. Right, so you can see at resonance the value of voltage is least 70.484 milli, or approximately you can say 0. Okay, now just to verify that, go to cursor through. So what you can do is you can click and bring it closer. Cursor through 150, 159.155. You are getting 87.630 to to the power minus 6 volts. So this is your y-axis, this is your x-axis. So we verified for 4 amperes, that is I max. We verified at F0 you have 4 max, at F0 you have 16,000, and at F0 the voltage across L and C is same, thus they cancel each other at resonance. Now we have to find your F1 and F2. So let me take current through capacitance or current through resistance. You will get same answer, that is 4 amperes. Now, so as Rohit has explained in theoretical calculation, you can go back to the video and refer. To find F1 and F2, we take or find out at RMS value. So that means, so 4 by root 2 is 2.828. So at 2.828 when I draw a line, so when I draw a line at 2.828 somewhere here, okay, it touches at 2 point. This is my first point, which is my first half power frequency, or one of my half power frequency. We have labeled it as F1, and along this line it touches on the curve at this point, right? And at this point it is my second half power frequency, that is F2. Now how do we do that? And the difference between those two is called as bandwidth. So 2.828, that is I max by root 2, it is 2.828. Is it on x-axis or y-axis? So 4 is on y-axis, so divide by root 2, 2.828 is also on y-axis. So I must draw a line along y-axis. So the code for that is SFLE 2.828, enter. Okay, so this is my F0, sorry, F1. Similarly, I'll just say cursor search and I'll say again OK. You can see it shifts for F2. So this is my F2, but I want bandwidth, right? So for that I'll place A1 at F2. I'll right click somewhere before my F1 and I'll type the code which is already there, right? And I'll just say OK, and you can see this is A1 is now F2, A2 is my F0, and the difference is my bandwidth. If you reverse your F1 and F2 with respect to A1 and A2, you'll get difference as negative. That should not be a trouble, but preferably this syntax is better, as you can say that A1 is nothing but F2, A2 is nothing but F1, and the difference between those two, that is A1 minus A2, that is F2 minus F1, is my bandwidth, that is 149.253 milli. So now we have found two half power frequencies. Now in your manual you can see we have to plot a graph in your graph sheets, right? So for that what you can do is in the table column you can observe. Let me show you a manual. So in this experiment, this is the table that you can see for different frequencies, what are your value of current and what is the value of voltages. Okay, now so let us go back to your waveform. Now, so let us say I have to take around 10 points. So let us say I click on this point, so I'll get the value of let me right click and make it to origin. So I have left click somewhere at this point and it is around 158.846. So let us say that my frequency is 158.846. At that time, what is the value of current? The value of current is 939.306 milliamperes. Okay, then next I'll take one more point. Let's say this point, it is 158.932, 158.932, and what is the value of current? The value of current is 1.269. Now in this order I have to take until the last row. At some point I have to take the peak value that is 159 point somewhere here in between, 159.155, and the current is 4 amperes, right? And then again I must take after that point 159.207. For example, you can take any point. You can also take at this point. I'm just taking at this dot. So 159.207, 159.07, and the value of current was 3.2776 amperes. Like that, we have to take until the last row. Now, after doing that, we have to also plot for voltage across capacitance. So for that, go to add trace, click on VC1, say OK. Delete your resistance. Now, we need to take for the same frequency. So what I'll do, I'll copy this, the one which I've written. Then I know the frequency is on x-axis. I'll go to cursor search. I'll say search for x value. Okay, and I'll say enter. So for this x value, I know what is my frequency, 3.76 k approximately, 3.76 k volt. Then next, I'll copy this x-axis. Go to cursor search. Change your x-axis, press enter. So at this time, the value of voltage is 5.08 kilovolt. So in this syntax, you have to do until here. So at resonance, we know it is 16 kilovolt, right? So similarly, after the resonance frequency, just search for other four frequencies, what is its value of current and voltage. So in this way, you have to plot, note down the data, and then plot your graph. So conclusion, the calculated values and observed values are approximately equal, and the respective graphs are plotted, hence verified. So kindly plot the graph and paste it in your lab manual.